is a question on the principle of conservation of momentum. Now I am going to state the principle. If in a certain direction no external forces act on a system, the total momentum in that direction remains constant. Before solving this question, I will explain this principle. In this, what is meant by a system? This system can be a system of bodies. Now this diagram shows two balls moving with the velocity v1 and v2 on a horizontal table. One body is A, one ball is A, other is B. Mass of this is m1, the mass of this is m2. Now this, we can consider this as a system. Suppose the velocity of B is v1, velocity of A is velocity of B is v2, and velocity of A is v1. Now A collides with B. At that time, the two velocities are v1 and v2. After collision, the velocity of B is x2. Let the velocity of B be x2 and the velocity of A be x1. Now we consider these two bodies as a system of bodies. Now the only forces acting on the bodies are these internal forces. This force, the force which is acting on B, acts in this direction. It is acted by A on B. Then a force, equal force, acts on A by B. It is in this direction. But there are no horizontal there are no external forces acting. These are internal forces. Now in this direction, that is in this direction, there are no external forces. So we can apply this principle of conservation of momentum. That is, the total momentum remains constant in this direction. Now what is the initial total momentum of the system? This is the initial diagram. That is, initial momentum is, momentum of A is m1 v1, the momentum of B is m2 v2. Then the total momentum, initial total momentum in this direction. Direction is also necessary. That is equal to m1 v1 plus m2 v2. Then what is the final total momentum of the system? That is equal to this m1, the mass of this is m1, mass of this is m2. Then final momentum of the A is m1 x1. M1 x1, capital X, m1 x1 plus m2 x2. This is the final total momentum. Now we can equate these two momentums. That is m1 v1 plus m2 v2 equals m1 x1 plus m2 x2. This is how to apply this principle of conservation of momentum. Now this is the sledge. There's a boy of mass 50 kilograms inside this sledge, and the sledge is moving with a velocity of 4 meters per second. The mass of the sledge is 20 kilograms. Now there are no external forces between these moving on ice. Then we assume that there are no resisting forces on this sledge. Now another boy is moving with a velocity of 12 meters per second. We have to find the mass of the boy. Let the mass of the boy be m kilograms. Now this is before the second boy jumps into this. The velocity of the boy is 12 meters per second. Now this boy comes from behind and jumps into the sledge. As soon as he jumped to the sledge, the velocity of the sledge changes. The speed of the sledge is doubled. Then what is the velocity? 8. Velocity 8 ms minus 1. First, the velocity of the sledge is 4. Now, when it is double, the velocity of the sledge is 8 meters per second. Now, we can take this sledge and the two boys as a system of bodies. Maybe we can consider it as a system of particles, because each body is a system of particles. Now, let us say that this is a system of bodies. Now, there is a reaction on the reaction at the feet, equal and opposite reactions. There's also another reaction, equal and opposite reactions. Those are internal forces. There are no external forces acting horizontally. So we can equate the initial momentum in that direction to the final momentum in that direction. We can equate those two. Now, what is the initial momentum of the system in this direction, horizontal direction? Equals the momentum of the sledge is 20 into 4. 20 into 4. This is the initial total momentum. That is, momentum of the sledge is 20 into 4. Then the velocity of this boy also, the velocity is this one. So the velocity of that boy equals 50 into 4. 50 into 4. Now the velocity of this boy, that is m into 12 plus 12m. 12m. This is the initial total momentum of the system. Now we have to find the final total momentum in that direction. Now when it is moving with this velocity, the velocity of this boy is also 8, and velocity of this boy also 8 ms minus 1. Now we can even write this way also. The momentum of this is m into 8, 8m, 8 into m, plus 50 into 8, 50 into 8, plus the mass of this sledge is 20 kilogram, plus 20 into 8, 20 into 8. But we need not write this in this way. We can add the mass of the three bodies, and then the momentum is total mass into 8. We can use that way. We can write in this way. The total mass is 50 plus 20 plus m, all in kilograms. That into velocity is 8 ms minus 1. Now we can equate these two. Now equating the momentum, we can write as 70 plus m into 8 equals is 80. 4 into 20 is 80. Plus 4 into 50 is, then is 200. 200 plus 12m. 12m is equal to 8 into 70, 56. 560 plus 8m equals this is 280. 280 plus 12m. then we get 4m equals 280. So m equals, therefore m equals 70 kilograms. That is the mass of the second ball.